One of the more controversial solutions to the effects of the climate crisis is geoengineering, which is, according to Harvard's Geoengineering research program, a set of emerging technologies that could manipulate the environment and partially offset some of the impacts of climate change. But what is the field's current state? As of June 2023, the European Commission does not consider geoengineering a viable solution to climate change, saying that it does not address the root cause of the problem, the increased global greenhouse gas emissions in the atmosphere. They then go on to say, in the current state of development, a deliberate intervention in the Earth's natural systems, such as a solar radiation modification deployment, represents an unacceptable level of risk for humans and the environment. However, they do recommend, as do the White House, a comprehensive research agenda that explores the risks and potential rewards of solar geoengineering. One of the biggest and seemingly unresolved issues of geoengineering is the idea of a termination shock. Put simply, it goes like this. Imagine technologies like carbon capture, nuclear fusion, or solar don't scale up quickly enough for us to avoid serious global warming. And to stop this, governments around the world make large deployments of solar geoengineering, enough to cool the Earth's atmosphere for a decade, masking the warming of the Earth. Well, yes, it might work for a while, but the stratospheric deployments only last for about 2 years. And so if there was ever an economic depression, war, or breakdown in international order, and the injections into the atmosphere stopped, the Earth's warming could be unmasked, leading to rapid rises in global temperatures. But is this a realistic possibility? Some argue that just because we've started using it won't necessarily mean that it can't be stopped. Volcanoes give us an insight into this. For example, the stratospheric aerosol release that occurs naturally following the eruption of a volcano typically lasts for about a year, so even if we did stop immediately, there wouldn't be a crazy rise in temperatures straight away. There is also the risk associated with cost, because it would, in theory, be cheap. This may mean irresponsible deployment from a single country, potentially leading to some form of political instability or conflict. One paper found that solar geoengineering could increase crop yields. Looking at 3 types of solar geoengineering, namely stratospheric aerosol injection, marine sky brightening, and cirrus cloud thinning on a range of crops such as wheat, maize, and rice. The researchers found that all 3 potential solar geoengineering methods have a strong cooling effect. Another benefit is that it could reduce sea surface temperatures. This could help to maintain coral reefs and reduce risks of bleaching events. Other potential benefits of solar geoengineering include the lessening of sea ice loss, frequency of extreme weather, water availability, and a reduction in tropical storms. So we've explored current policy, risks, and potential benefits, but do we have any examples in recent times of geoengineering experiments? Following the coral bleaching of the Great Barrier Reef in 2016, the world mourned. Following this, a group of researchers from Australia's Reef Restoration and Adaptation Programme began pilot testing marine cloud brightening, a form of geoengineering that involves spraying microscopic sea water droplets in the air. As of October 2023, the group has now gone beyond proof of concept and is starting to investigate the response of the clouds. In 2022, startup Make Sunsets performed a stratospheric aerosol injection into the atmosphere. A leading figure in the field, David Keith, said in a blog post, "Commercial development cannot produce the level of transparency and trust the world needs to make sensible decisions about deployment." After 390 climate scientists suggested a ban on SRM, Mexico decided to ban commercial deployment, and according to Reuters, Make Sunsets have since put aside plans for a new launch. Although it isn't strictly solar geoengineering, some have argued that an unintended form of geoengineering has taken place, which may help to understand the field's complexities. Global temperatures took a sharp turn upwards in autumn 2023, leaving climate scientists and the general public in a state of shock. But why? Some believe it was a form of geoengineering in reverse, caused by low sulfur shipping rules. To put it simply, between 1970 and the 2010s, SO2 emissions from marine fuel have increased from 1 megaton to about 10 megatons, which is known to have severe health implications and reportedly leads to about 19,000 to 91,000 deaths in coastal regions each year. This led to stricter shipping rules, but unintentionally the sulfur was actually cooling the oceans. In other words, we were doing a form of geoengineering without knowing it. When the rules came into place, sulfur in the oceans decreased and temperatures rose. Whether we can understand complex systems enough to deploy solar geoengineering in a safe and effective way is something that seems unanswered. But governments and scientists alike seem to generally believe that the most responsible thing to do is to research it in detail. I'll leave you with this. Frank Koich, a professor working on Harvard's ScopeX program, said, "As a scientist, I am not saying we should do solar geoengineering. In fact, I am quite terrified. But the key thing is that solar geoengineering has the potential to bring real benefits for people and ecosystems, compared to emission cuts alone. Maybe it's that potential we should explore, but as a complement to emission reductions, not as a replacement."